your F-150 EcoBoost has factory settings quietly cooking your wastegate, and you would never know until the check engine light comes on and a repair bill hits $1,800. Most owners think their truck is running perfectly, while these settings slowly destroy one of the most critical parts of the turbo system. I have been a Ford technician for over 16 years, and I see melted wastegates and warped actuator linkages every single week. Today, I am exposing 5 factory settings and engineering defaults that are quietly executing your turbocharger system without you ever knowing. Setting number 3 has caused some of the most frustrating premature failures I see in the shop. But setting number 1 is so deceptive that owners actually think it is beneficial to their truck when it is doing the exact opposite. Let's get into it. Setting number 5 is the lack of an automated turbo cool-down cycle, paired with the factory default instrument cluster that hides your actual turbo temperatures. When you are under boost, pulling a trailer, or even just running 70 miles per hour down the highway, your turbos are spinning at speeds up to 150,000 revolutions per minute, and the exhaust gases passing through the turbine housing reach temperatures exceeding 1,500 degrees Fahrenheit. The wastegate assembly sits directly in this superheated exhaust stream. The common behavior for 99% of owners is to pull into a driveway or gas station after a hard run and immediately turn the key off. Ford says nothing on your dashboard to warn you against this, but here is the hidden mechanical reality of what happens the second that engine stops. The moment the ignition kills the engine, the mechanical oil pump drops to 0 pressure. The oil that lubricates and cools the turbo bearings stops circulating instantly, but that 1,500-degree heat does not just disappear. It undergoes a destructive process called heat soak, with no fresh oil flowing to carry the heat away. The residual thermal energy radiates outward from the turbine housing directly into the wastegate actuator, the linkage, and the surrounding electronic sensors. The stagnant oil trapped inside the red-hot turbo bearing cartridges instantly cooks, breaking down chemically and turning into hard carbon deposits in a process known as coking. I have pulled apart countless turbo assemblies where these hard carbon particles have migrated out, circulating into the tight clearances of the wastegate mechanism and grinding the internal bushings to dust. Over time, the actuator cannot move freely. It binds and sticks, forcing the electronic actuator motor to draw excessive amperage to move the unlubricated linkage, which ultimately warps the linkage rod and burns out the motor entirely. The solution is completely free and takes exactly 60 to 90 seconds. After any heavy towing or highway driving, let your truck idle before shutting it off. Keeping the engine idling keeps the oil and coolant circulating through the turbos, dropping the turbine housing temperature by several hundred degrees before the flow stops. Ford buries a brief mention of a cool-down period deep inside the digital owner's manual under severe duty definitions, but dealerships never explain it, leaving you to cook your components in silence. Setting number 4 is one that Ford markets heavily as a major fuel-saving benefit, but under everyday driving conditions. It is creating the exact high-stress environment that destroys electronic wastegates, the factory auto start-stop system. You know how it works. You pull up to a red light, the engine shuts off completely, and then it fires back up the millisecond your foot lifts off the brake pedal. Ford engineered this system to meet strict EPA fleet certification requirements, not to prolong the lifespan of your powertrain every single time your EcoBoost engine shuts down at a traffic light. The oil pressure feeding the turbochargers completely collapses. While the engine is off, the water pump and oil pump stop, causing an immediate spike in localized temperatures around the wastegate flapper valve and actuator arm. Then, when the light turns green, the engine fires back up, sending a sudden shock of cold oil and exhaust gas through the system. This creates a relentless cycle of extreme thermal expansion and contraction. Fluctuating hundreds of degrees dozens of times during a single commute, the metal alloy used in the wastegate bushings and linkage joints was never designed to endure this frequency of rapid thermal cycling. I have personally inspected wastegate actuators on trucks with heavy city start-stop usage at 40,000 miles that exhibit the exact same mechanical play loose tolerances, and linkage elongation that I would normally expect to see on a highway-driven truck with well over 100,000 miles. When that linkage develops even 1 or 2 millimeters of slop due to worn bushings, the computer loses precise control over boost pressure, causing the actuator to constantly hunt, overcorrect, and slam the wastegate closed. To stop this cumulative damage, you need to develop the habit of pressing the Auto Start Stop override button on your dashboard every single time you start the truck. Because Ford ties this feature directly to the vehicle's emissions certification, they are legally barred from allowing you to permanently disable it through the factory sync menus. If you want a permanent fix so you do not have to remember it every time you turn the key, look into an aftermarket Start-Stop Eliminator module. These cost around $100 to $150 and plug directly into your switch harness to safely maintain the off setting. When you calculate that a factory electronic wastegate actuator replacement costs $400 to $700 in parts alone before you even factor in 5 hours of book time labor at a shop, spending a little bit of money or changing your startup routine makes financial sense incredibly fast. Those first 2 settings are bad enough, but the next 2 are where I see owners completely accelerating the demise of their turbo system without realizing they are doing anything wrong. Setting number 3 is a factory feature designed for fuel economy that is actually a mechanical nightmare when your truck is working hard. Eco Mode paired with high gear transmission programming, your F-150 comes equipped with multiple selectable drive modes, and millions of owners switch their trucks directly into Eco Mode, thinking they are doing their wallet a favor, especially when pulling a trailer or climbing a steep grade. The factory programming for Eco Mode is strictly written to upshift the transmission as early as possible and hold those tall gears, like 8th, 9th, and 10th, for as long as humanly possible to keep engine revolutions per minute incredibly low. On a flat highway with an empty bed, that is perfectly fine. But the moment you put a heavy load behind the truck or hit a hill in Eco Mode, you force the engine into a highly destructive condition known as lugging. When you lug an EcoBoost engine, you are operating at a low engine speed under an immense torque demand. Because the transmission refuses to downshift to maintain fuel economy metrics, the engine computer has only one tool left to meet your power request. It demands maximum boost pressure from the turbos to build that massive boost at low engine revolutions. The computer commands the electronic wastegate actuators to slam the wastegate flappers completely shut and hold them there against an absolute wall of high-pressure exhaust gas. This creates a worst-case scenario for the turbo system. At low engine speeds under heavy load, the exhaust gas temperatures skyrocket rapidly, frequently crossing 1600 degrees Fahrenheit. The wastegate flapper and its sealing seat inside the turbine housing are subjected to maximum thermal load and immense physical pressure simultaneously. Because the power demand is inconsistent as you try to maintain speed, the computer panics and forces the actuator to rapidly cycle, slamming open and shut with extreme frequency under maximum heat to bleed off sudden spikes in pressure. This high-frequency cycling under peak thermal stress acts like a hammer to the internal components. It quickly deforms the wastegate flapper valve seat, creates excessive play in the actuator arm, and literally bakes the electrical insulation inside the actuator motor. I have pulled down countless trucks where the owner towed in Eco Mode, and the wastegate flapper was so badly warped it could no longer seal against the housing, resulting in a permanent underboost code and a dead turbocharger. The solution is simple. Completely banish Eco Mode whenever your truck is working. If you are towing anything over 3,000 pounds, hauling a heavy load in the bed, or driving through mountainous terrain, immediately engage TOW Haul Mode. This factory setting completely rewrites the shifting logic, downshifting aggressively to keep the engine up in its natural power band. By letting the engine spin faster, the truck can use mechanical RPM to make power rather than forcing the turbos to create maximum boost at low speeds. This drops your exhaust gas temperatures significantly, stabilizes boost delivery, and stops the frantic, high-temperature cycling of your wastegate components. Setting number 2 is a behavioral habit directly enabled by Ford's lack of safety limiters on cold engine operation. Aggressive driving immediately following a cold start. Most owners treat their modern truck like a smartphone. Turn it on, put it in drive, and immediately pull out into heavy traffic, demanding sudden acceleration and high boost while the truck is still cold. The factory settings allow the computer to give you full boost almost immediately after turning the key, hiding the mechanical reality that your engine is completely starved for proper protection. When you first start your EcoBoost on a cold morning, the engine oil is thick, viscous, and sitting entirely in the oil pan. It takes time for the oil pump to push that cold lubricant through the incredibly narrow feed lines that supply the turbocharger bearings and the moving parts of the wastegate mechanism. The tight clearances inside the turbocharger assembly are specifically engineered around oil that has reached its full operating temperature and proper viscosity. When you stomp on the gas pedal with cold oil, you force the turbochargers to spin up to 100,000 RPM instantly. Because the oil is too thick to flow at its engineered rate, the turbo bearings experience momentary starvation, creating microscopic wear. Simultaneously, the electronic wastegate actuator is forced to push and pull its linkage against incredible resistance because the thick, cold oil and carbon residue around the pivot bushings act like sludge rather than a lubricant. The actuator motor has to work twice as hard to move the arm, drawing massive current and wearing out its internal gears. Worse yet is the phenomenon of thermal shock. When you demand heavy boost on a cold engine, you send a sudden blast of 1500-degree exhaust gas directly into a wastegate flapper and turbine housing that are sitting at freezing or ambient temperatures. This extreme, instantaneous temperature differential causes uneven metal expansion. The thin metal of the wastegate flapper expands much faster than the heavy cast iron of the turbine housing. Over thousands of cold starts followed by immediate hard acceleration, this thermal shock distorts the wastegate seat, causes the linkage joints to crack, and causes premature failure of the actuator's electronic internal components. The fix is entirely free and requires only a tiny bit of patience. You do not need to sit in your driveway and let the truck idle for 15 minutes, which actually causes excessive fuel dilution in the oil and carbon buildup on the direct injection valves. Instead, start the truck, wait about 30 seconds for the initial high idle step-down to occur, and then drive the truck gently for the first 3 to 5 minutes. Keep your throttle inputs light, keep the engine speed moderate, and stay completely out of heavy boost until the temperature gauge on your dash moves up to its normal operating position. This allows the oil to warm up, thin out, and fully coat every critical clearance inside the turbos and wastegates before they are subjected to extreme heat and pressure, saving the entire assembly from invisible, cumulative destruction. Now we have reached setting number 1, and this is the absolute pinnacle of factory deception. It is an engineering default that millions of F-150 owners actively praise because they think it proves their truck is running flawlessly, when in reality, it is the number one reason EcoBoost turbos and wastegates end up completely ruined before the truck even hits 100,000 miles. I am talking about the factory-programmed oil life monitor and the absurd 10,000-mile extended oil change interval. Ford's marketing team and dealership networks love to advertise these massive oil change intervals because it lowers the advertised cost of ownership and makes the truck look low maintenance on paper. The truck's computer uses an algorithm based on engine revolutions, operating temperatures, and drive times to calculate your oil life percentage, and it routinely tells owners they can drive 9,000, 10,000, or even 12,000 miles between oil changes. Most owners look at that digital dashboard display, see oil life 40%, and confidently drive cross-country under heavy load, believing the factory oil is protecting their high-tech powertrain. But here is the brutal mechanical reality that Ford doesn't tell you. That interval is a death sentence for your turbocharger system. An EcoBoost engine is not a naturally aspirated V8. It is a highly sophisticated, direct-injected, twin-turbocharged beast that runs incredible cylinder pressures and extreme thermal cycles. Because it is direct injected, these engines inherently suffer from fuel dilution, where raw gasoline seeps past the piston rings and enters the engine oil, especially during short trips. At the same time, the positive crankcase ventilation system constantly routes oil vapor and unburnt hydrocarbons right back through the intake. By the time that engine oil hits 5,000 or 6,000 miles, its viscosity is heavily degraded by fuel, and it is completely saturated with microscopic carbon soot when you push that dirty, diluted oil out to 10,000 miles just because the dashboard says it is okay. You are circulating liquid sandpaper through the tightest clearances in your entire vehicle. The bearing cartridges inside your turbos spin at blinding speeds and rely on a pristine film of high-quality oil to stay suspended. When that oil is thinned out and full of carbon, it fails to maintain that critical protective barrier. The turbo bearings run hot, and that excessive heat cooks the degraded oil into hard carbon coking deposits during normal operation. These abrasive carbon particles quickly escape the bearing housing and migrate directly into the electronic wastegate pivot bushings and actuator. Linkage pins. The wastegate flapper mechanism requires precise, low-friction movement to control boost. When it is flooded with carbon soot from worn-out oil, the metal-on-metal joints begin to grind, score, and bind. The electronic actuator motor now has to fight against a sticking, jammed mechanism. To overcome the resistance, the actuator motor draws massive electrical current, overheating its internal circuit board and warping the thin control linkage. When I tear down a failed EcoBoost turbo in my bay, the very first thing I do is pull an oil sample. Without fail. The trucks with seized wastegates and blown turbo bearings are the exact same ones, whose owners religiously followed the factory 10,000-mile oil life monitor. The solution to this problem is non-negotiable if you want your truck to survive. Completely ignore the factory oil life monitor. Throw that 10,000-mile interval completely in the trash. You need to change your oil every 5,000 miles or 6 months, whichever comes first. Using a top-tier full synthetic oil that meets or exceeds Ford's strict WSS M2C961A1 specification, paired with a high-quality filter. If you tow heavy trailers, haul equipment, or live in a severe climate, drop that interval down to 4,000 miles. Cutting your oil change interval in half costs you an extra $60 a year, but it prevents a $4,000 dual turbocharger replacement down the road. Clean oil keeps the turbo bearings cool, stops coking before it starts, and ensures the electronic wastegate linkage never gets jammed with destructive carbon deposits. When you look at the big picture, your F-150 EcoBoost isn't failing because it is a poorly engineered truck. The EcoBoost platform is an incredibly capable, high-performance power plant that can easily run for hundreds of thousands of miles. The problem is that the factory settings, the emissions-focused programming, and the lack of upfront warnings from the manufacturer are quietly working against the mechanical longevity of your turbo system every single day. By taking control of your truck's operation, you completely rewrite that narrative. Let the engine idle for 90 seconds to cool down after a hard drive instead of shutting it off hot. Turn off the auto start-stop system the moment you start the truck to protect your bearings from constant pressure drops. Stop towing in eco mode and switch to tow haul to drop your exhaust gas temperatures. Drive gently for the first few minutes of a cold start to let the oil warm up and lubricate the wastegate joints. And finally, change your oil every 5,000 miles to keep the entire system pristine. None of these fixes require a massive mechanical toolkit or a fat wallet. They simply require a change in your daily habits and a little bit of insider knowledge. If you found this information valuable and want to keep your truck out of the repair shop, make sure to hit that subscribe button and drop a comment below, letting me know which of these factory settings you are going to change today. Share this with every EcoBoost owner you know, because thousands of them are melting their turbo systems right now without ever knowing it. Take care of your truck. Stop letting factory defaults dictate your component lifespan, and I will see you in the next shop breakdown.